The purpose of this lab is to compare an observation of an object's motion that is moving at the same speed without changing direction to a computational model of that same object using Newton's second law. This law allows us to bridge the impact of properties from our system and measure its impact on the motion. In this case, since the forces from the surroundings cancel out to equal a net force of 0, that results in a constant velocity. Using this theory, this model predicts the future positions of the object through the initial position, velocity, and the delta time. Furthermore, deriving a formula from Newton's second law, we get two different formulas. One is position update formula, and the second one is velocity update formula. However, for the purpose of this lab, velocity update formula is negligible, since the net forces equal to 0, the final velocity equal the initial velocity, thus indicating that final velocity equals the average velocity. This is the video I recorded. In this video, the object is a canned food moving across a plane that is the wooden floor for a time duration of 0.75 seconds. I decided to make the object roll towards the negative x-axis. I calculated the distance moved by the object by taking the measurement of the canned food's bottom diameter and then using the stick to measure the distance in the video. The timestamp for each frame is 0.017 seconds. Lastly, I decided to record in the middle of the video because if I had started at the beginning with the initial push, it would have skewed the velocity as the net force would not be 0. Now we'll take a look at my video. This is the code that I used to predict the object's future position using the initial values from the observational video. Let's take a look more closely. I set the ball mass equal to 0.482. However, this does not matter since it cancels out due to net force being 0. I set the initial position and velocity and the delta t to equal that of the observed object. The time duration to be 1 second, which means how long the program will last. The net force to be 0 to get the constant velocity. As shown before, we are using two formulas derived from Newton's second law. This is the main one that we'll be using. This is the position update formula. Now let's take a look at the program run. As you can see, the program has worked properly. This way being the negative x-axis, this way being the positive x-axis, positive y-axis, and this way being the negative z-axis. This graph is the comparison of the position of the observed to that of the computational one. The blue line is the observed and the red line is the model. Initially, the two objects are about the same position, but as time increases, the blue line's position increases less and less, thus giving us a considerable differences between the two lines towards the end of the data. This is largely due to it being impossible to have a net force of 0 in real life. Furthermore, the errors from my observed are mostly due to there being friction with the wooden floor, the canned food having food inside, and the angle of the video, as you can see, is a bit slanted, and the air resistance in the room. We could improve the data if we're able to account for the friction of the forces of friction and air resistance in our model, and if I were able to improve the angle of the recording and remove the insides of the canned food. First question. The only thing that would change if I flip the axis, the graph would show that the position is going in the positive direction and the velocity would be positive rather than negative. The reason the flipping the axis does not change the result in major way is because the only thing being affected is the unit vector, which is the direction the object is going in. So it would just change between negative and positive, but the quantities would be the same for position and velocity. Second question. It is possible to show pushes and pulls that are added together to give a net force of 0. The prime setting would cause the gravitational force and the normal force to cancel each other out, as the object is not moving up or not moving down. and there would need to be no friction because the surface would be frictionless. Thus, since no other forces are acting on the object and interacting with it, the object would keep moving at the same speed as after the initial push the object was given.